Okay, so the next one is analysis of variance. And really, that's what we call ANOVA, is kind of the short version of that, the acronym that we use for it. So before, what we looked at was situations where we compared one group to some hypothesized standard, which was a one sample, and two groups to each other, which is a independent. But often the situation arises, more often than not, that you want to compare more than two groups. So for example, we want to compare 6th graders, 7th graders to 8th graders. You can't run 3 t-tests. You can't run a test that compares 6th grade to 7th grade, 7th grade to 8th grade, 8th grade to 6th grade. Because every time that you do that, you create error. And if you start doing that over and over, you keep compounding the error. And there's a really strong chance that you will say something that's true that's not, which we don't want to do. So that's why we have our friend the ANOVA. It's made for multiple groups. They can get extremely complicated. So we're going to for now, we're going to stick with something pretty simple that compares one independent variable between multiple groups. So we're going to make the same assumptions we did with the independent t-test in terms of normality, independence, homogeneity, and variance. And we're going to test a null hypothesis. So suppose we're comparing the IQ scores of undergraduates, graduates, and faculty members. Under the null hypothesis, we would say there is no difference in IQ scores between these three groups. So hypothetically, let's assume we reject the null. That would mean there is a difference between those three groups. The challenge with an ANOVA is we probably aren't satisfied with this statement. We want to know, where is the difference? Who of these three groups, if they're different, is the smartest one? And there's a solution to that as well. So for now, what we're going to do is we're going to use an example of some graduate student data about computer experience as an independent variable. And when I mean computer experience is they've had 1 week or less, between 1 week and a month worth of experience, 1 month and 6 months, between 6 months and a year or more. So even though I was assigned a numerical value to these, they're simply placeholders for these categories. And we have a interval scale that measures their attitudes towards computer anxiety, computer confidence, how much they like computers, and how useful they find computers. And that's the independent variable. So we wanted to determine the extent to which this variable influences or creates differences in these variables. So our research question would be is what difference is there in computer anxiety, confidence, likability, usefulness in regard to the amount of time that a student spends on a computer. So when you run the ANOVA, you get a data table that looks like this. So here's, again, the computer experience. These are their scores on their computer anxiety. So we had, in this group, we had 9 people who had 1 week or less. Their computer anxiety score was a 21.3. There's the standard deviation, standard error, the minimum score, the maximum score, and the confidence intervals. So for group 2, those between 1 week and 1 month, there was 10 of those. Here's their score, standard deviation, minimum score, maximum score. That's the computer anxiety. Then it goes to the computer confidence score. And again, these numbers will be the same. We had 209 total participants. Most of them had a year or more worth of experience with the computer. So here's the confidence scores, likability scores, usefulness scores. And it's the same stuff over and over. Are they the same shapes? In terms of how these numbers are distributed, the means and the standard deviations across all these groups, all these numbers are larger than 0.05. So we're good. We don't have anything to fix there. So here's the ANOVA. So what this tells us is for computer anxiety, we know that not everybody within the groups, so for computer anxiety, we had 5 groups, but not everybody has the same score. Look at the range on these: 13 to 30, 11 to 34, 20 to 40, 16 to 39, 20 to 40. What we really want to know with an ANOVA is the difference between the groups, the 5 groups of no experience up through a year or more worth of experience. Is that difference greater than any difference within a single group? So what it's doing is it is trying to take, it is not trying to, it is taking this data and it's trying to see at what point does this number, along with its associated standard deviation, separate itself from any of these others? Where is the set breaking point between here and here? And what we discover is there is a difference between these groups for anxiety, confidence, likability, and usefulness, because the significance value is all less than 0.05. Now, again, we ask the question up here, are we satisfied with this? No, we're not. When you get that, it says, yeah, there's a difference between these 5 groups. The next thing that people want to know is, okay, well, where is it? And there's another test for that called the post hoc test. I don't think this is really the right time to get into that, because you're going to learn a lot more about that process. At this point, you just need to know that there is a way to determine the extent to which or where the differences are in these groups.